everyone, myself Dr. P. Soumya, working as an assistant professor in the Department of Chemistry, Institute of Aeronautical Engineering College. In this session, I am going to discuss about renewable energy sources. So in this session, I am going to cover the topics solar energy, wind energy, hydropower energy, and biomass energy, and also geothermal energy. So these all are renewable energy sources. So renewable energy sources, what is the definition of renewable energy sources? So this renewable energy, it is derived from natural sources that are regenerated or replenished at a higher rate than they consumed. So renewable energy, it is energy derived from natural source so that are replenished or regenerated at higher rate than they are consumed. So these are renewable energy sources. Examples of renewable resources, these include solar energy, wind energy, hydropower energy, hydropower and biomass energy, and also geothermal energy. So here solar, this is about solar energy. So solar energy, it is harnessed through the use of solar panels which convert sunlight into electricity. So in this solar energy, so this is harvested or harnessed through the use of solar panels, so which are converted sunlight to electricity. So it is a clean renewable resource. It is a clean and renewable resource of energy, so that can be integrated into energy system to reduce reliance on fossil fuels. So this is example of renewable source, that is solar energy. It is harnessed to by using solar panels. Solar panels, these will convert sunlight into electricity. So here next is wind energy. So wind energy, it is generated by wind turbines. So that convert kinetic energy of wind into electrical energy. So here in case of solar energy, so here we are converting solar energy into electricity. So in wind energy, so here this wind energy, that is kinetic energy, is converted into electricity, that is electrical energy. So it is sustainable and abundant source of energy, so that can be integrated into energy system to supplement other renewable sources. Third one is hydropower. Hydropower, it is generated by capturing the energy of flowing or falling water and converting into electricity. So this is generated by capturing the energy of water, flowing water or falling water. So this is converted into electricity. The energy converted into electrical energy. So it is reliable and renewable source of energy, and these can be integrated into energy system to provide the stable power supply. So next, biomass energy. This biomass energy, it is derived from organic materials such as wood, crops, agriculture waste. So biomass energy, it is produced by using organic materials such as wood, crops and agriculture waste. So it can be converted into heat or electricity. So this energy, biomass energy, it is converted into heat energy or electricity through process like combustion or anaerobic digestion. So biomass energy, it can be integrated into energy system to reduce reliance on fuels, fossil fuels, and manage the organic waste. So geothermal energy, it is derived from the heat of the earth core. So this is derived from the heat of earth's core. So it can be harnessed through the geothermal power plants to generate electricity, provide heating and cooling for buildings. So this is harnessed through geothermal power plants, so to generate electricity, or we can provide the heating or cooling for buildings. So here geothermal energy, it is a sustainable and renewable resource, and it is a reliable source, so that can be integrated into the system to reduce greenhouse gas emissions. So here this is about solar energy. So this introduction to solar energy here. Solar energy, it is a renewable source, means it can be regenerated and replenished. So this is the source, energy source that has gained significant attention in the recent years. So it is harnessed from the sun and it is converted into usable electricity through various technologies. through various technologies. So here we are converting solar energy into electrical energy, and here harnessing, how to harness the solar energy. This is harnessing of solar energy. Solar energy, it is harnessed through the use of solar panels, also known as photovoltaic panels. The solar panels are also called as photovoltaic panels. So these panels are made up of solar cells, so that converts sunlight into electricity. Solar panels, so these are also known as photovoltaic panels. So these are made up of solar cells. These will convert sunlight into electricity. So converting solar energy, so this is the process of converting solar energy into usable electricity. It involves the use of inverters. So it involves use of inverters. In this case, we are using inverters. So here, inverters, these convert direct electric current. So DC current, so this electricity, DC current electricity, it is generated by solar panels into alternative current. These inverters, so these are converting the DC to AC, and that can be used for power homes, business, and other electrical devices. So photovoltaic cells, so these are known as solar cells. So they play crucial role in converting sunlight to electricity. So these photovoltaic cells convert sunlight into electricity. So here we have different types of photovoltaic cells. So here monocrystalline silicon cells, polycrystalline silicon cell, thin film cells. So here, so three types of photovoltaic cells are there. So each with its own unique characteristics and applications. So each photovoltaic cell, it is having unique characteristics and applications. So in monocrystalline silicon cells, so these are made from single crystal structure. Monocrystalline silicon cells, these are made from single crystal structure, so making them highly efficient and expensive. So they are commonly used in residential and commercial applications. So monocrystalline silicon cells, these are commonly used in residential as well as commercial applications. So here polycrystalline silicon cells. So these polycrystalline silicon cells, these made from multiple crystal structures. So these made from multiple crystal structures, which reduces their efficiency compared to monocrystalline cells. However, they are more affordable and widely used in large scale solar installations. So here next third one is thin film cells. So these thin film cells are made by depositing a thin layer of semiconductor material on a substrate. So these thin film cells are made by depositing a thin layer of semiconductor material on a substrate. So here these are flexible, lightweight, and cost effective, making them suitable for applications such as building integrated solar panels and portable devices. So because these are having these are lightweight, flexible, and cost effective. So that's why these are used in used as a portable devices. So what are the applications of solar energy? So we can use in residential, commercial use. So this is having solar farms, and so we can use the solar energy in solar powered vehicles. So first one is residential use, that is solar panels. It is installed on residential rooftops and to generate electricity for home use. So the rooftops, the residential rooftops, these can be used for the generation of electricity, which is used for the home. And next, commercial use, solar panels installed on commercial buildings to generate electricity for business operations. So solar farms, large scale solar power plants, so that generate electricity for the grid. So this generate electricity for the grid. So next, solar powered vehicles that are powered by solar energy, reducing reliance on fossil fuels. So these can be used as solar powered vehicles, and we can use in solar farms, and we can use in solar that business purpose and also homes. So what are the advantages of solar energy? So this is having renewable nature, low environmental impact, and also potential for cost savings. So here solar energy, it is a renewable energy source, meaning it is continuously replenished by the sun. So it is continuously regenerated by the sun. So this makes it sustainable and environmentally friendly option for generating electricity. So this is very sustainable and environmental friendly option for generating electricity because it is renewable resource. So here low environmental impact. Solar energy, it has a low environmental impact compared to fossil fuels. So it does not produce greenhouse gas emissions. So solar energy, it is low environmental impact compared to fossil fuels. So here it does not produce any harmful gases, that green gas emissions or air pollutants, reducing the negative effects on, it will reduce the negative effects on climate change and air quality. So here this the solar energy, so this does not produce greenhouse gas emissions or air pollutants. So this will reduce the negative effects on climate changes and air quality. So potential for cost savings here, solar energy can lead to significant cost savings in the long run. So once the initial installation cost is covered, the solar power, it is essentially free. So and reducing or eliminating electricity bills, it will reduce the electricity bills. Only initial installation cost is after initial installation cost. So that power which is produced by the solar panels, so this is free and this will reduce or eliminating the electricity bills, and additionally excess electricity that generated can be sold back to the grid. So if excess electricity is generated, so that can be sold back to the grid and providing a potential source of income. So these are the advantages of solar energy. So here next is wind energy. This is another renewable resource. So here wind energy, it is a renewable energy source. So that has gained significant attention in recent years. So here it harnesses the power of wind to generate electricity and providing a sustainable alternative to traditional fossil fuel based energy sources. So here the wind turbines are the key technology this used to convert wind energy into electrical energy. So these consist of large blades mounted on the tall tower. So when the wind blows, it causes the blades to rotate. So when wind comes, the blades rotate. The wind causes the blades to rotate. So the rotation of the blades drives a generator which produces electricity. So here the wind in this consists of wind energy in these turbines. So these are consist of large blades mounted on a tall tower. So when the wind comes, it causes the blades to rotate. The rotation of the blade, it drives a generator. That generator produces electricity. See, so here wind energy is converted into electricity by using wind turbines. So here wind turbines, these are the devices that convert kinetic energy of wind into electrical energy. Here kinetic of energy of wind energy is kinetic energy of wind, it is converted into electrical energy using wind turbines. Here they consist of several components that work together to harness the power of wind and generate electricity. So these wind turbines, these are having several components. So these are working together to produce electricity from wind energy. So here the components of wind turbine, it is 5 components are there. First one is rotor, second one is generator, third one is tower, and the fourth one is nacelle. So fifth one is control system. So rotor, first is rotor. So it is having rotor, generator, and also tower, nacelle, and also control system. So here first rotor, it consists of 2 or 3 blades. So it consists of 2 or 3 blades that capture the wind energy. So the wind energy, it is captured by the blades which are in the wind turbine. So here when wind blows, it causes the blades to rotate. When wind blows, that wind causes the blades to rotate. So here generator, next component is generator. So the rotating blades these turn a generator. The rotating blades turn a generator which converts mechanical energy into electrical energy. So third one is tower. This tower is used as a support. So here this supports the rotor and generator at a height where the wind is stronger and more consistent. So it is used as a support to rotor and generator at a height and where the wind is constant and stronger. So it is very consistent, more consistent and stronger. So here next component is nacelle. So the nacelle, it is located at the top of the tower and it contains the generator grade box. It is contain generated gearbox, so and other components. So it is nacelle is located at the top of the tower and it contains the generator and gearbox and other components. So control system, the control system monitors the wind speed and the direction. It adjusts the position of the rotor. So control system, it is used for monitoring wind speed, wind rotation, that is direction, and it adjusts the position of the rotor. So it regulates the electrical output and also it regulates the electrical output. So these 5 are components of wind turbine. So these are work together to harness the power from the wind energy. So here onshore versus offshore wind farms. So some of advantages and disadvantages are there. Onshore wind farms and offshore wind farms. Here advantage of onshore wind farms, we have lower installation and maintenance cost is here lower installation maintenance cost is there in onshore wind farms. These are easier access for maintenance and repairs. So less complex logistics for construction. So these are also having disadvantages. So limited available land and potential for visual impact. So for onshore wind farms, limited available land is there. So here noise and disturbance for nearby communities takes place. Because of onshore wind farms, noise and disturbance for nearby communities takes place. Here, what are the advantages of offshore and wind farms? So these are stronger and more consistent wind resources. So offshore, so comparatively onshore, offshore stronger. So these are offshore wind farms. These are stronger and more consistent wind resources. So here, in less visual impact on land and potential for larger capacity. Here these can reduce the noise and disturbance for nearby communities, and these are the disadvantages. This is also having some disadvantages. So higher installation and maintenance cost. So whereas onshore, so this is having lower installation maintenance cost. So for offshore, we will higher installation maintenance cost is more. So it is challenging logistics for construction and maintenance. So here for construction and maintenance, this is very challenging. So for offshore wind farms, these are 2 types. We have wind farms, onshore and offshore. So these are advantages and disadvantages of onshore versus offshore wind farms. So here, what are the benefits? Benefits of wind energy. What is the importance of wind energy? So here, this is it's having renewable nature, low environmental impact, and potential for cost savings. So here, we know that wind energy is a renewable energy source. So we know the meaning also. So here, this is derived from a source that is naturally regenerated, replenished. So here, that is wind. So unlike fossil fuels, which are finite and contribute to climate change, wind energy, it is sustainable and it does not deplete the natural resources. So we know that fossil fuels, these are finite and these contribute climate change. But wind energy, it is sustainable, it does not deplete any natural resources. Here it is low environmental impact. So one of the key benefits of wind energy is its low environmental impact. So here, wind turbines generate electricity without emitting greenhouse gases and or other air pollutants. Here we are using wind energy to convert into electricity. Here, while generating electricity, here no emission of greenhouse gases and other air pollutants takes place. So this the wind energy, the wind turbines, these generate electricity without emitting greenhouse gases and other air pollutants. So they do not produce harmful byproducts or contribute to climate change. So additionally, wind energy production So this requires minimal water usage compared to other energy sources. So in this case, it requires wind energy, it requires minimal water usage as compared to other energy sources. So this will reduce the strain on water resource. This impact, it will reduce the strain on the water resources. So potential for cost savings. So wind energy, it can provide potential cost savings for both individuals and business. So once a wind turbine is installed, so as same like solar energy. So as once a wind turbine is installed, the cost of generating electricity from the wind is relatively low, and this can lead to long-term savings of energy bills, so like electricity bills. And additionally, wind energy can create economic opportunities through job creation and investment in the local communities. And it is benefit. These are the best benefits of wind energy. And it is having renewable nature. It is having low environmental impact, and it is also having potential for cost savings. So overview of hydropower. So we have discussed about solar energy and wind energy. Next energy is hydropower. This hydropower, it is a renewable energy source that harnesses the power of flowing or falling water to generate electricity. So here, the power of flowing or falling water, it is converted into electricity. So in hydropower. So here, hydro means water. Here, hydro, by using water, here we are generating the electricity. So that is power of flowing or falling water. It is converted into electricity. So it is one of the oldest and most widely used sources of renewable energy source with a long history of providing electricity to communities around the world. So here different types of hydropower systems are there. So first one is conventional hydropower system. So here conventional hydropower system, it involves the construction of dams or reservoirs. So in conventional hydropower system, so this involves construction of dams and reservoirs to store water. So when the water is released, it flows through the turbines. So which generates electricity. So in conventional hydropower system, so it involves the construction of dams and reservoirs to store the water. So when this water is released, it flows on the turbine, which generates the electricity. This type of hydropower system, it is commonly used for large scale power generation. So this type of conventional hydropower system, it is used for large scale power generation. Second one is runoff river hydropower. Runoff river hydropower systems do not require the construction of dams or reservoirs. So in case of conventional hydropower system, so that require the construction of dams and reservoirs, whereas runoff river hydropower do not require the construction of dams and reservoirs. So instead they use natural flow of river to generate electricity. So here for producing runoff river hydropower, so they are using natural flow of river to generate electricity. So here water is diverted from the river and passes through turbines. In this case, water is diverted from the river and that passes through the turbines. So these turbines, we know that this generate electricity, that is power. So here this type of hydropower system is often used in areas with a consistent flow of water. So this type of runoff river hydropower system, it is used in areas with a consistent flow of water. Third system is pumped storage hydropower system. So here pumped storage hydropower systems, these involve two reservoirs located at different elevations. So in pumped storage hydropower system, so this involves two reservoirs located at different height, the different elevations. So during the period of low electricity demand, excess electricity is used to pump water from lower reservoir to upper reservoir. So when electricity demand is high, the water released from upper reservoir and flows through. So these are flows through turbines to generate power, that is electricity. So here we have two reservoirs located in different elevations. When during the low electricity demand, the excess electricity it is used to pump water from the lower reservoir to upper reservoir. When electricity demand is high, the water is released from upper reservoir to lower reservoir and it flows through the turbine to generate electric current. So here this type of hydropower system, it provides a way to store and release energy as needed. So this system provides a way to store and release energy as our requirement. Here effects of environmental impact by hydropower. So this is having effects on aquatic ecosystems and also potential for habitat disruption. So here hydropower can have significant effects on aquatic ecosystems. So the construction of dams and reservoirs can disrupt the natural flow of rivers and this alter the habitats of aquatic organisms. So this effect is the hydropower, it's showing effect on aquatic ecosystem because the construction of dams and reservoirs, this can disrupt the natural flow of river and alter the habitats of aquatic organisms, and it is potential for habitat disruption. So the creation of reservoirs for hydropower can lead to the flooding of large areas of land, resulting in the loss of habitats for both terrestrial and aquatic species. So additionally, the altered flow of water downstream of dams, this can affect the availability of food, breeding grounds for aquatic organisms. So this is the environmental impact by hydropower system. So what are the future trends in hydropower? Here, some smaller scale hydroelectric systems and integration with smaller scale hydroelectric systems. So this is the future of hydropower lies in the development of smaller scale systems. So the future of the hydropower, it lies in the development of smaller scale systems that can be implemented for various locations, including rivers and canals. So this is the future. So future of hydropower, it lies in the development of smaller scale systems. So that can be implemented in various locations, including rivers and canals. So these systems are more cost effective and environmentally friendly and making hydropower accessible to a wider range of communities. So this will make the hydropower accessible to wider range of communities. So integration with other renewable energy sources. So here hydropower, it is being integrated with other renewable sources such as wind, solar power and to create hybrid systems. So this integration allows for a more stable and reliable energy supply as well as increased efficiency in harnessing renewable energy. So this is about biomass energy. So we have discussed about solar energy, wind energy and also hydropower. So this is about biomass energy. This is introduction about biomass energy. This biomass also renewable energy source. So that is derived from organic matter such as plants, agriculture waste, crops and forestry residues. So it is a promising alternative to fossil fuel. So it is a promising alternative to fossil fuels. So that has the potential to reduce greenhouse gas emissions and dependence on non-renewable resources. So this biomass energy, it is derived from organic matter such as plants, agriculture waste and forestry residues, also crops. So types of biomass. Here there are several types of biomass that can be used for energy production. So here these are three types. First one is wood and wood residues. Second one is agriculture crops and residues. And third one is algae. So in this wood and wood residues such as sawdust, wood chips are commonly used as biomass feedstocks. So in wood and wood residues, so In this case, wood and wood residues can be used such as sawdust and also wood chips. These are commonly used as biomass feedstocks. So they can be burned directly to produce heat or converted into biofuels like wood pellets and liquid biofuels. So by using this, wood is converted into heat energy and also into biofuels like wood pellets and liquid biofuels. So next one is agriculture and crops. Agriculture crops and residues. So these agriculture crops and residues such as corn stalks, wheat straw and sugarcane bagasse and can also be used as a biomass feedstocks. So these are crops, agriculture crops. These can be used as a biomass feedstocks. They can be converted biofuels, biogas, and also used directly for heat generation and power generation. So this can be used for used as a biofuels, biogas, and it is used directly for heat and production of heat energy and electrical energy. So third one is algae. So this algae is a versatile biomass feedstock that can be grown in various aquatic environment. So algae, so we know that this feedstock that can be grown in various aquatic environments. So it can be converted into biofuels such as biodiesel and biogas and also has a potential to be sustainable source of energy. So by using algae, we can produce biodiesel and biogas. So here these are the types of biomass energy. So here we have different conversion technologies are there for converting biomass into different energies. So here biomass, it is converted into various forms of energy using different technologies. Some common conversion technologies, this include, first one is combustion, second one is gasification, third one is anaerobic digestion. Anaerobic digestion, combustion, gasification, anaerobic combustion, and aerobic digestion. So these are the various these are the technologies which are used for the conversion of biomass into different forms of energy. So here combustion, biomass, this can be burned directly to produce heat and electricity through combustion. In this, combustion takes place. Here this biomass, this is directly burned in presence of oxygen, that is called as combustion. So this is a common and widely used technology, especially for wood and agriculture biomass. So this type of technique is used for, especially for wood and agriculture biomass. Here gasification. Gasification, it is a thermochemical process. Gasification, it is a thermochemical process. It converts biomass into gas mixture. This called syngas. That is called syngas. That is synthetic gas. So in this gasification, this is a thermochemical process. In this biomass is converted into gas mixture. That is syngas. That is synthetic gas. So this syngas, this can be converted for heat and power generation or further processed into biofuels and chemicals. Here anaerobic digestion. So in this anaerobic digestion, it is a biological process and that breaks down organic matter into the this is break down the organic matter in the absence of oxygen. So anaerobic digestion means in absence of oxygen. Here a breakdown of organic matter takes place in absence of oxygen and it produces biogas which can be used for heat, electricity or upgraded which can be used for production of heat and electricity, or this is upgraded to biomethane which is used for vehicle fuel. It is used as a fuel for vehicles and injection into the natural gas grid. So by using anaerobic digestion, here we are producing heat energy, electricity and also so the biomethane which is produced by anaerobic digestion, it is used as a vehicle fuel. So these are the conversion technologies of biomass energy into different forms of energy. So applications of bioenergy and these considerations. Here applications of bioenergy. Bioenergy, it can be converted into various applications including heat and electricity generation. So this can generate heat energy and also electricity. Here heat generation, this bioenergy, it can be converted. This can be used to generate heat for residual, commercial and industrial purposes. And biomass. So this biomass, such as wood pellets and or agriculture residues. This can be burned to produce heat. So heat energy here by in this bioenergy in this converted into heat energy. This heat is used in residential, commercial and industrial purposes. In this biomass such as wood pellets and agriculture residues, these can burn for the production of heat energy. Here electricity generation, bioenergy, it can also be used to produce electricity. So this biomass, this can be burned in power plants. So in this for the generation of electricity, this biomass, it can be burned in power plants to produce steam. So here, which drives the turbines to generate electricity. So in this case also, here this biomass is used for production of heat energy. So this heat energy is used for the production of steam. So this steam is which drives the turbines to generate electricity. So that's why this is having applications in heat generation and electricity generation. So here, environmental and sustainability considerations for bioenergy. So here, while bioenergy has the potential to reduce green gas emissions and dependence on fossil fuels, there are also environmental and sustainability consideration associated with biomass. So some key considerations, these include sustainable biomass supply, land use change and air quality. Sustainable biomass supply, land use change and also air quality. So here, ensuring a sustainable supply of biomass, it is crucial to avoid deforestation and other negative impacts on ecosystem. So second one is converting land for biomass production can have unintended consequences such as loss of biodiversity or competition with food production. And air quality, the combustion of biomass, this can release the pollutants and harmful gases such as particulate matter and nitrogen oxides. So when biomass is undergoing combustion, it will produce some gases that like nitrogen oxides, which can have negative impacts on air quality and human health. So these are the considerations: sustainable biomass supply, land use change, and also here biodiversity change, biodiversity. So loss of biodiversity takes place, and also air quality also decreases by the use of bioenergy. Here next energy is geothermal energy. So this is introduction about geothermal energy. It is a renewable energy source that harness the heat from the earth's core and it generate electricity and heat buildings. Here there are two main types of geothermal systems. In this case, geothermal energy. So it is a renewable source. This harnesses the heat from the earth's core. So this harnesses the heat which is produced, which is coming out from the earth's core. So that is converted into electricity. And also used as a heat buildings. Here, so we have two types of geothermal systems. First one is geothermal power plants. Second one is geothermal heating systems. Here, geothermal power plants. So these in geothermal power plants, so this can use steam or hot water. So this can use steam or hot water from the underground to generate electricity. So here in geothermal power plants, so in this case they can use steam or hot water from underground to generate electricity. So this is done by drilling wells into the earth crust to access the geothermal reservoirs. So this is done by the drilling wells into the earth crust to access the geothermal reservoirs. So the steam or hot water, here we are using steam, we are using water. So the steam or hot water, it is then used to drive the turbine. The steam or hot water which is coming out from the geothermal reservoir. So this is used to drive the turbine, so which generate the electricity. Here geothermal power plants are typically located in the areas with high geothermal activity such as volcanic region. So in volcanic regions, we will find the geothermal reservoirs. In that case, we have to drill the wells. So by the drilling wells into the earth crust to access the geothermal energy reservoirs. So the steam or hot water which comes from the reservoir, it is used to drive the turbines. From that we can generate the electricity. Here the geothermal heating systems. Second one is geothermal electric systems, heating systems. Here geothermal heating systems, in this case use of natural heat from the earth to warm buildings. So here in this case we are using natural heat from the earth to warm the buildings. Here this is done by circulating water or a refrigerant through pipes buried underground, so which absorb the heat from the earth. So in this case we are circulating, this is done by circulating water or a refrigerant, so through the pipes, so buried underground, which absorbs the heat from the earth, the heated water or refrigerant. So here we are passing the refrigerant or water through the underground pipes. So these will absorb the heat from the earth, and the heated water or refrigerant, it is then pumped into the buildings. It is then pumped in the hot water that is pumped into the buildings. This will heat the building system. So this will heat the building, and this will providing the warmth. This will provide the warmth for the buildings. Here the geothermal heating, these systems are sustainable and also energy efficient alternative to traditional heating systems. So these are sustainable and these are renewable energy resources. So emerging technologies. We have two technologies for geothermal energy, conversion of geothermal energy into electricity. Here first one is enhanced geothermal systems. Second one is binary cycle power plants. So by this technology, we can convert geothermal energy into electricity. In this enhanced geothermal system, it is a technology that involves drilling deep into the earth crust. So here we are drilling deep into the earth crust to access geothermal resources. To access the geothermal resources, first we have to drill deep into the earth crust. So water, in this case, water is injected. Water is injected into the wells to create fractures in the hot rocks. So in this case, water is injected into the wells, so to create fractures in the hot rocks. If we send water through the water tracks, so it will get fractured. So the fractures can take place by using water. So in this case, we are drilling the deep into the earth crust, and also here water is injected into the wells to create the fractures in hot rocks. So the heated water, so this is fractures takes place, and also the water get heated. The water get heated, so the heated water, the hot water, then pumped to the surface. Then this water, it is pumped to the surface, so which generates electricity. So that is here hot water that is pumped to the surface. This will generate electricity. So this is the technique, that is enhanced geothermal system. In this, so this involves drilling deep into the earth crust. In this case, water is injected into the wells to create the fractures on the hot rocks. So when it hits, the water is heated on the hot rocks, so the water get heated, and the heated water then it is pumped to the surface to generate electricity. Here next is binary cycle power plants. So here binary cycle power plants, so these are another form of geothermal energy technology. So they use the secondary fluid. In the first AGS, here we are using water. In this we are using water. So that is, here we are using water. So in case of binary cycle power plants, so here we are using secondary fluid with a lower boiling point than water. So here we are using some liquid, that is fluid, which is having lower melting point, lower boiling point than water. So to capture heat from the geothermal reservoir. So here in case of AGS, here we are using water. In this case we are using, in binary cycle power plants, here we are using the liquid, that is fluid, which is having lower boiling point, water, to capture the heat from the geothermal reservoir. Here the heat is transferred to the heat exchanger, so where it is vaporizes, and the secondary fluid, which then drives the turbine to generate electricity. In this case here the secondary fluid, so it vaporizes as temperature is more in geothermal reservoir, so it will drives the turbine. It will drives the turbine, so to generate electricity. So these are the emerging technologies for generating electrical energy from the geothermal energy. So here, what are importance of renewable energy? We have discussed about different types of renewable energy sources, so like solar energy, wind energy, and also hydropower, geothermal energy, and also biomass energy. So what is the importance of renewable energy? So here, renewable energy, it plays a crucial role in addressing the growing concerns of climate change and also need for sustainable alternatives to traditional energy sources. So we are using traditional energy sources like fossil fuels and like coal and petroleum. So we need a transition to traditional energy sources. So we have to use renewable energy sources like solar energy, wind energy, geothermal energy, etc. So as the demand for energy continues to rise, it is becoming increasingly important to transition to renewable resources, so that are not only environmentally friendly but also abundant and readily available. So these renewable resources, these are abundant and also generated by nature. So here renewable energy sources, these are, we know that solar energy, wind energy, hydropower, geothermal power, and these will having several advantages over fossil fuels. Firstly, they produce little to no greenhouse gas emissions. So most of the renewable energy sources does not produce any greenhouse gas emissions. So this reducing the carbon footprint and mitigating the effects of climate change. And as additionally, renewable energy, it is a sustainable solution as the sources are naturally replenished and will not deplete over the time. So this will not deplete over the time. This will regenerate again and again. So here furthermore, the adoption of renewable energy can lead energy independence and security. So unlike fossil fuels, which are often imported and subject to price fluctuations. So in case of fossil fuels, because of importation and exportation, so here this will take price fluctuation takes place. So for non-renewable resources, here renewable energy resources, this can be harnessed locally. So this will reduce reliance on foreign energy sources and also promoting economic stability. It will promote the economic stability. So here this is the importance of renewable energy. So that's why here transition, that is to the need for sustainable alternatives, as we continue to rely heavily on fossil fuels for our energy needs, it is becoming increasingly clear that we need to transition to more sustainable alternatives. So the environmental impact of traditional energy sources, it is significant and has led various issues such as air pollution, climate change, and resource depletion. So if we use non-renewable resources, it will take the disadvantages are there, that is it is having various issues such as air pollution, climate change, and also resource depletion. So whereas the renewable energy, this will offer the viable solution to these challenges. By harnessing natural resources such as sunlight, wind, and water, we can generate clean and sustainable energy without contributing to greenhouse emissions and also depleting finite resources. So here there are several benefits and of transitioning to renewable energy sources. So already we have discussed the advantages of renewable energy sources. So here secondly, the renewable energy sources, these are abundant and widely available. So we know that these are abundant and widely available. So unlike fossil fuels which are finite and concentrated in a specific regions, in case of fossil fuels these are concentrated in specific regions. Renewable, so these are renewable resources. These are distributed globally, like solar energy, wind energy, geothermal energy. So these are distributed globally. So whereas fossil fuels, these are finite. These are only concentrated in specific regions. So this means that the countries can tap into their own renewable energy potential, reducing dependence on imported fuels, enhancing energy security. It will enhance the energy security. Here lastly, the development and adoption. The development and adoption of renewable energy technologies, these can drive economic growth and also create job opportunities. So here, this development and adoption of new renewable energy technologies, so this can drive economic growth and also it will increase the job opportunities. So here the renewable energy sector that has been growing rapidly in recent years, so attracting investments and creating a wide range of jobs in areas such as manufacturing, installation and maintenance of renewable energy systems. Here this sector is rapidly growing. So in this manufacturing, installation, maintenance of in the areas of installation, manufacturing and maintenance of renewable energy systems. So here this is conclusion. So here we have discussed what is a renewable energy source. So we know that this is having a crucial, it's playing crucial role. So and it is a crucial in transitioning to the more sustainable and clean energy future. So wind, solar, hydroelectric power, these are some of the most viable renewable energy sources. Renewable energy, these can reduce the gas emissions and also dependence on fossil fuels. So this will reduce the dependence on fossil fuels. So what is importance here? Renewable energy resources, this plays a vital role in addressing climate change and also mitigating its effects. So by utilizing wind, solar, hydropower, and we can reduce we know that we are reducing the greenhouse emissions and also dependence on dependence on the fossil fuels. So here the transition is more the transitioning it is to a more sustainable clean energy for future is essential. It is very essential to transition from more sustainable fossil fuels to renewable resources. It is very essential for preserving environment and also ensuring the livable planet for the future generations. So for preserving the environment and also ensuring the livable planet for future generation. So this transition is very important from fuel that is fossil fuels to that is non-renewable resources to renewable energy resources. So this is about renewable energy sources and thank you.
Like, share and subscribe. Hit the bell icon for more updates.